Okay, so all right, we are live now. Let me paste the YouTube link on calendar so you can access from the calendar. Okay, so regarding resources, right? So you can go on the portal. There are lots of things under FAQ and all you can access, and there is textbook also. How any one of you seen the textbook or no?
Sir, which one?
Yes,
Like
see.
probability by the Shiva Atreya, that one?
Uh, Yeah, that you
Week
can see
week
also.
wise
Is my screen
textbook,
visible?
sir.
Is my screen
PDF one.
is my
The
screen?
week wise textbook you are talking about.
Yeah, so there is one practice book you can see, and there is weekly notes also. You can
Yes, sir.
go through that also, right? So this weekly notes contains, something. You can say basically, let's say this is week 3. Okay, if you will click here, you see the PDF. Basically, kind of summary of all the contents which has been
Yes,
covered
sir.
in.
And these are notes and
Yes, yes. So it's kind of notes and all. So
yes,
try
sir.
to do, like more number of problems, and there I think on the portal itself you can find sufficient amount of questions. Okay. The one thing you have to do, I mean, you have to practice a lot more without. Let's say you are going to attempt any solution. Sorry, any question. Okay. So do not see. Try to see the solution at the same time. Okay, just try to attempt, take 5 minutes, 7 minutes, whatever. Try to think about the question, just split the question, and whatever the things just try to apply, whether you are able to apply or not. And at the end, after 2 or 3 times, if you are not getting, then you can see the solution and all. Okay, everything is there, and we will upload the practice assignment solution for week 3 and week 4 also. Don't worry, by tomorrow it will be there. Okay, so let's try to understand the content of week 3. Okay, will that be all right for everyone? We will
Yes, sir.
discuss the concept and try to solve the questions, whatever the concept we are going to discuss.
So
Okay.
week 3 is the application portion of stats one.
Yeah, actually, see, stats 2 itself, you can see this is one step ahead, no, one level up of the statistics 1 course. Okay.
Okay,
Yeah.
sir.
It's so as of now you can see we are still in discrete random variable only, right?
Yes,
So
sir.
we saw in week 1 we started with the 2 random variable, then we saw something about multiple random variable, then functions of the random variable, then we will see expectation, variance, covariance. I mean, that's which we are going to discuss in today's session. Okay, so we'll try to. Okay, so
So small doubt
sorry.
regarding the extra activities. I have a small doubt.
Okay, can we discuss at the end? Will that be all right? If
Yeah, okay, sir.
okay,
And
yeah,
that
yeah.
means they've asked just screenshot. Yeah, okay.
Sorry.
Your voice is
I've
cracked.
asked to take a screenshot of collab notebook.
Okay, okay. So just go through the whatever the steps are there. There can you mute yourself? There is a background noise. Yeah, thank you. Okay, so just follow the steps whatever mentioned there. If not, don't worry, we will discuss here then. Or else, for the safe side, what I would suggest, just post on the discourse, okay? And we can have a discussion there, right? So there people can answer also. So Madhav, first of all, I will basically go through the summary, then I will take the doubts. Okay, will that be all right? I think.
Okay, sir.
Okay, yeah.
That would be all
Okay,
right.
okay. So okay, great. So let's start the expectation. I think the something expectation you have learned in statistics 1 course. So I would like to hear from you. What do you mean by the expectation? What's the role of expectation? That's something which you can recall. Don't worry about whether you are going to say wrong, right. Don't worry. This is not something grade or any punishment or something. Just whatever the something you can share, and then I will get to know what are the things you know. Okay. So what's the role of expectation? Anyone? Anybody?
It basically represents the average value after a long run. of the
Okay.
random variable.
Okay. Okay. That is the definition of expectation. Correct. Why? What's the need? If
So
I will
what,
rephrase my question.
sir, what basically we expect from the outcome of the event? Basically, what are we expecting as a result? That is
So
actually
expecting from outcome, is this correct?
expecting.
Yes, sir.
Expecting from random
Expecting
variable.
from the expression, yeah, from the random
Random variables.
No. Okay. Suppose I'm saying X is the outcome if I'm rolling a fair die. Okay, six-sided fair die. Then, if you will calculate expectation of X, okay, I will show you how to calculate. Let's say this is 3.5. So does this mean if I will roll a die, then I will get the outcome 3.5? Is the meaning of this or something else?
No.
Hmm.
No.
Something else, sir.
Yeah. So I want to listen that something else.
When we actually
Yeah, Ravi Sekhar is somewhat correct. Correct. So it represents single for a populace. Yeah, go ahead. Someone is saying something. Yes. No one? Okay, all right. So, yeah, everyone were correct. Okay, so let me say, explain. So, suppose I'm saying I have X as a discrete random variable is taking some values x1, x2, let's say countably finite values, okay, up to xn.
Mean value. We can.
suppose expectation is 3.5, but in a long run, when we do a experiment for
Mhm.
longer duration, we reach to the nearest value. Means
It's a average of all the outcomes, all the results. If you are, let's say you are rolling a die 1,000 times, okay,
yeah.
then average of those outcomes, okay, if you'll take that will close to the expectation, okay.
Yes, sir.
So actually, what's the need? If I will say in layman terms, let's suppose I have to explain. So okay, first of all, what is the probability mass function of a discrete random variable? So x is taking some value x1, x2, xn, and with the probability, let's say p1, p2 up to pn. Okay, and what are the conditions? All the probabilities should be between 0 and 1. Summation of all the probabilities should be equal to 1. Then this is the valid probability mass function. Okay, would you agree with me? Now my question is, if you have information about your random variable, okay, suppose I'm saying you have all the information about your random variable. I mean, what are the possible values your random variable is taking, and what are the corresponding probabilities associated with each values of x. Then why we are interested in expectation?
For taking the account what will happen in the
variable. We want to understand the behavior of the random variable.
Behavior of the random. Okay. Okay. Correct.
we
So
are
okay. So if I will say, suppose I'm saying, if I want to explain my random variable in a single value, then this expectation of x will help me because it will give you some central idea about your random variable. Yes or no? If you okay, suppose I'm saying you want to represent a college. Okay, let's say you want to represent a college in terms of placement, then you will say on an average placement of that college is, let's say, 12 lakh per annum. Okay, so what you are saying, in a single value you are representing the placement status of that particular college. Yes or no?
yes sir.
So if I want to explain my random variable in a single value, so in that case expectation helps us. Okay, is this okay? Are you getting idea?
Can you explain
Yes.
more time, sir?
Yeah, okay, suppose I'm saying there is a college, let's say college A. Okay, you want to give the status of that placement cell. So if you are saying on an average the placement status of that college is, let's say, 12 lakh per annum. Okay,
Yeah.
so what you are saying, you are explaining the placement status in a single value only.
Yes.
Correct. Let's say you want to explain or else you can say average marks of this particular class is 90. That means you have some sort of ideas, you have some central idea about that particular class. Okay, this class is students of this class is good because average marks is 90. Yes or no?
Yeah.
So if you want to explain your random variable in a single value, then expectation of random variable will help you. So what is the expectation of x? It's just nothing but long run average. Okay, how you can compute mathematically? So expectation of x is nothing but you have to do x1 into probability that x is taking value x1 plus x2 into probability that x is taking value x2 plus so on xn into probability that x is taking value xn. Okay, so I can write x1 p1 plus x2 p2 and plus so on xn pn. So if you want, I can write like this: summation I is equal to 1 to n xi probability that x equal to xi, or you can write summation of xi or pi. Also this is possible, right? This can take some like infinitely countable values, right? Yes or no? So this, in that case, this will be summation I is equal to 1 to infinity xi probability that x equal to xi. The only thing you have to assume here, this summation, this sum exists. Okay, this sum exists. Okay, so you can assume the sum exists. So what do you mean by exist? Anyone?
There are finite number of elements in this group.
Exist means, yeah, its summation shouldn't be diverged, right? I mean, it shouldn't be infinity. Okay.
Yes, sir.
So I will take one very simple example to understand the expectation, then we'll move ahead. So let's say I have a random variable x. I will take very simple example. Suppose x is taking value 1, 2, 3, and 4, and the corresponding probability with each values for let's say this is 1 by 4, 1 by 4, 1 by 4, and 1 by 4. Then what is the expectation of x? How will you proceed? So x1 into corresponding probabilities. So 1 into 1 by 4 plus
2 into 1 by 4.
very good. 2 into 1 by 4 plus 3 into plus 4 into 1 by 4. So it will be 4, 3, 7, 2, 9, 110, 10 divided by 4. So 2.5. Okay. So expectation of x for this particular example is 2.5. Okay. Anyone, any doubt?
Sir, can you explain the difference between PMF and expectation once again?
So there is not, these two are separate things. See, PMF will tell you the whole information about a random variable. Okay. So what is the PMF? PMF tells you the probabilistic behavior at each point of your random variable. So what do you mean by probabilistic behavior? So suppose I'm saying x is taking value x1, then what is the probability that this random variable will take x1? X is taking value x2, then what is the probability that x will take value x2? Similarly up to xn. Expectation of x is nothing but it will give you the single value. Okay, so expectation is nothing but it's a long run average. Okay, so let's say you are you are rolling a die. Okay, then so if you are rolling a die, let's say 1,000 times. Okay, then average of all the outcomes of this 1,000 will be close to expectation of that random variable. Okay, fine.
Yes, sir. Thank you.
Yeah.
So,
So
how to do,
mhm.
sir, how to do for summation for infinity? You wrote above in the slide.
Yeah, here it means it can take lots of values, right? So we don't infinitely, it can take very I mean, it's countably infinite values.
Okay,
I mean,
sir.
you can count, but you don't know. Let's say you know 1, 2, 3, 4, 5, but you don't know the last limit. Okay, but you can count. But that's why it's a
Yes.
discrete. Okay.
Yes, sir.
So example for this is you can see the Poisson distribution, geometric distribution. All this comes under the this condition. So I will, okay, one more thing. Do you want to derive me the expectation of geometric and all, or it's fine, or should I
So
take it?
derive.
No, sir. No, sir.
Sir,
No, sir.
it will be fun.
So okay, I will derive for geometric only. Okay, I will
Yes,
take
sir.
one example from here, and I will show you how to proceed with this kind of question, and then I will move ahead. Okay. Now, so if you see, the question says by investing in a particular stock, a person can make a profit of 10,000 rupees in 1 year with a probability of 0.55. So, and or take a loss of 5,000 with a probability of 0.45. So what is the possible values your X is taking here?
10,000.
So this is, so X is taking
10,000.
10,000. What is the probability?
0.55.
0.55. So this is the profit, and it's a take a loss of 5,000 rupees with the probability of 0.45. That means what? Minus 5,000, right?
Yes.
Because it's a loss. Okay. So you have to be careful whenever there is any scenario about, I mean, this kind of scenario. Okay. So X will take value 10,000 with probability 0.55, and it will take value minus 5,000 because it's a loss, and for this loss probability is 0.45. So you have to calculate the expected gain. So gain means what? It's not asking expected profit. It is asking expected gain. So that means expectation of X will be 10,000 into 0.55 minus 5,000 of 0.45. So basically this will be 5,500 minus this will be
2250.
2250. So okay, then 3250 is the answer.
Yes.
Okay, so you can see, right? You are able to do, yes or no?
Yes, sir.
Okay,
Yes,
so
sir.
everyone has pen and paper.
So what is
Everyone
the
has,
difference
Yes,
between
we were able to
expected?
do everything.
okay. So if that is okay, then can you solve this question? Do not tell me the answer directly, because if I will click here check answers, I can get the answer. The one thing I would like to hear from you, how will you proceed? I mean, how will you define your random variable, or what are the possible values X will take, and then and so on.
Sir, which question?
Question number 5.
May I?
You can take 2 minutes and let me know. Yes, Safri.
Sir, I was asking in the previous question, you said that there's a difference between expected gain and expected profit.
Actually, sometimes people get confused. If I will write expected profit, then they will do only this. They are not taking the loss
Oh,
thing.
okay.
So
Okay,
that's
sir.
why I mentioned expected gain means you are considering both, right? Profit as well as loss.
Loss. Yes.
Yeah. I think similar question is this here about here. Okay. Okay. Anyone would like to explain to everyone?
May I?
Yes. Please go ahead.
Sir, we will take the probability of these all values that we are saying for will get the particular amount. So the 160 would be minus, and other two would be positive. So we'll take 1/6 into 100 plus 1/6 into 150 minus 160 into 1/6. So that would be the total money that.
Correct. So here you can see question is about play. The game is to be played with a single fair die, right? So that means probability it's about fair die. Then probability for each outcome will be 1/6. Yes or no?
Yes.
Right. So if that is the case, then if you see, so it is asking about this is question number 5. So what is your random variable X? So let's say X will represent the money to be won. Okay. So X will take 100 rupees because it is asking about win, right? Then if a 3 turns up, and 150 if a 5 turns up, right? So this is 150 again win, right? But loses amount 164 turns up, right? So that is 160 minus
160.
right? So what is the probabilities associated with each values? Because this you will get 100 when if 3 is there, right? If 5 and 4, right? So that means what? Eventually it's about getting the outcome of the after rolling a die, right? So that means probability will be 1 by 6, 1 by 6, 1 by 6. Yes or no?
Yes.
So expectation of x will be 100 into 1 by 6 plus 150 into 1 by 6 minus 160 into 1 by 6. So whatever the answer is there, you can solve. Basically, it will be this 15 numerator part. It will be 100 plus 150 minus 160 divided by 6. So it will be 190, right? Basically.
Yes, sir.
And,
Yes.
15 is the answer. Correct.
Sir,
Okay.
we are not 3 turns of 5 turns of what is the meaning of, we cannot include this in a
No,
problem.
how will you include? So if you read the question carefully, so it is asking about when 3 turns up, then you will get 100 rupees, right? So, and if you see, you have to calculate the expected money to be won, right? So how much money you are getting, right? So that means your X will be the amount which you are winning amount, basically, right? Then
Right.
X will be what? In terms of rupees only, right? So when basically when you are getting 100, when 3 is there, I mean, you roll a die, you got 3, that means your random variable will take 100 rupees. If you roll a die, if you 5 turns up, you will get 150 rupees. Roll a die, you got 4, that means you have to lose, I mean, your amount of 160. That means what? And at the end, so okay, tell me, to getting 100, what is the probability? 1 by 6 only, right?
1 by 6.
Yes.
Okay. Now is it clear? If you solve this next question, then I will move ahead. Okay. So okay, let me solve it. So I mean, you have to be careful, I think, about this question basically. So question number 6 is, suppose that a game is to be played with a single biased die. This is not a fair die. I mean, we don't know the probability for each outcome. The numbers from and the for each outcome probability is not same. That's why it's a bias. The numbers from 2 to 6 are equally likely to land face up, and number 1 is thrice as likely as to other face, right? That means what? So 2 to 6, suppose 2 to 6,
Yes.
till 2 to 6, right? So you are, okay, let's say outcomes will be 1, 2, 3, 4, 5 and 6. So 2 to 6 probabilities will be P, just assume, okay? Because if you see 2 to 6, if these faces are equally likely, right? But 1 is thrice. That means for 1, it's a 3P. Would you agree with me?
Yes.
Yes, sir.
Yes, sir.
Right. But you don't know the value of P. How will you proceed value of P?
Total is 1.
Summation
Total
1.
is 1.
It
That
is-
means 8P equal to 1, 3,
Yes.
this and 5. That means P is equal to 1 by
8.
8.
8.
Now, if you read the question, I mean, question is the same actually. 100 is 3, 150 is for 5, and you will lose 160. So basically, your random variable will take 100 with, now probability got changed here, right? 1 by 8 here. Yes or no?
Yes.
Is the question clear? Initially, question was about
Yes, sir.
fair die. I mean, you know, probability for getting each outcome is 1 by 6. But here in this case, when dice was biased, I mean, you don't know whether it's 1 by 6 or 1 by 7 or 1 by 8, right? Clear?
Yes, sir.
Yes.
Okay. Okay, then I will derive the expectation of geometric, and then we'll move ahead. Okay. Okay, till this point it's clear, the idea behind expectation of, okay. All right, yeah. Okay, so if you see the geometric distribution, so let me,
Sir,
sorry,
8 number question.
sorry,
Sorry,
Eight
sir,
number.
7 number.
what is the issue with this?
So not getting correct answer.
I mean, what was your approach? I would like to hear from you. How did you start it?
Sir, I was started that this they are saying the find the
Hmm,
expected value of discrete random variable.
correct.
That 4 choose CX. That I have done the probability that 1 upon 16 that 4 choose X then 1 upon 16. I got the probability is coming 1 but answer is 2.
No. So you did 4C,
X.
then how did you get 1?
So that n is 4, then I am getting answer 1, sir.
No, okay. I think, see, if that's why I'm saying, I told you, okay, just try to apply the concept very carefully. So what is the expectation? Expectation says what are the possible values x is taking, okay? Then what is the probability associated with each value? Let's say p1, p2, and pn, okay? I will tell you the two approach for that particular question, which I can see right now. So you have random variable x and PMF, let's say f of x, that is probability of x equal to x is 1 by 16, 4cx for the what values of 0, 1, 2 up to 4, right? That means what? Your x is taking these many values. Okay, so one request to all of you, if you do not have any doubt, okay, so kindly keep mute. Okay, so here x is taking what are the values? 0, 1, 2, 3, and 4. Yes or no?
Yes, sir.
Yes, sir.
What is the probability associated with each one?
So 1 by 16,
1
4
by
c,
1 by 16.
1 by 16, 4c, what?
x equal to 0, 1.
0.
0, right?
1, 2,
4C2.
Right?
4C3.
Yes, sir. Yes.
I think you added all this and you got 1, right?
Yes, sir.
No, sir.
See, expectation is what? There is some background noise. Have you joined with 2? So expectation is nothing but U2. If you see, so expectation is nothing but summation of x into probability, right? So U2 do 0 into this probability plus 1 into this probability plus 2 into this probability plus 3 into this probability plus 4 into this probability. Then you will get answer as 2. Okay? Is it clear now? So one is smart approach from where if you know, I can tell you. So one by Abhishek, can you mute? I think. Yeah. So if you don't have doubt, so please. So it's a 4cx, right? So you can see x is taking value 0 to n. Basically, n means still 4 only. So can I represent like this? This is 4cx, 1 by 2 raised power x, and 1 by 2 raised power 4 minus x. Can I write?
Yes.
What is this? This is PMF of
Binomial
with parameter 4 comma half.
1 by 2. Yes.
And what is the expectation of binomial? N into
NP
4 into 1 by 2, which is
2.
But this is the shortcut. But I mean, you can proceed with this. Okay.
Can you just show that, sir?
Which one?
The shortcut?
1 second. Shortcut means you had to identify this is the binomial. That's all. Okay.
Yeah.
Yeah.
Okay.
So in case of geometric distribution, so I'm doing derivation, then I will move it. So geometric P. Okay. So what is the probability mass function? So I'm taking one form only, right? So that is there is two form of geometric distribution. So 1 minus p raised to power t minus 1 into p. So this will represent basically number of trial to get the first success. If you are interested number of failure to get first success, then PMF will be 1 minus p raised to power t into p. In that case, t will be 0, 1, and so on. And here t will be 1, 2, 3, and so on. Okay, is the difference clear?
Yes.
Okay, so here x will represent the number of trials to get the first success. Okay. Now, so how will you proceed for expectation of x? So you know expectation of x is nothing but summation of, let's say, t will be from 1 to infinity, correct? And t into probability that x equal to t. Basically, t is nothing but you can replace with x. So this is just a notation. So summation t is equal to 1 to infinity. This will be t into this probability. Yes, no?
Yes.
P you can take outside of the summation.
Yes.
Okay. All right. Now from here, let's try to split. So I mean, let's try to apply. So if I will apply, I mean, just substitute the values. If you substitute the value t, 1, I mean values of t, then it will be 1 minus p raised power 1 minus 1, 0, 1 into, then 2 into 1 minus p raised power 2 minus 1, plus 3 into 1 minus p raised power 3 minus 1, plus so on.
Yes.
Yes, sir.
Right? So basically what you are getting, p 1 plus 2 into 1 minus p plus 3 into 1 minus p square. Similarly, you will get 4 times 1 minus p raised power whole cube. Yes or no?
Yes.
Yes, sir.
Yes.
So this is your okay, for the safe side, because this is not giving you any kind of GP, right? Direct GP. Okay. So what I will do, I'm going to represent this summation, this inside the bracket, this one. I'm taking as a S. Okay. Let's say 1 plus 2, 1 minus 2p plus 3, 2 into 1 minus p, 3 into 1 minus p whole square plus 4 into 1 minus p whole cube and so on. So what I will do to make it in a GP form, I will multiply with 1 minus p. So this is just a basic mathematics, okay? So if you will multiply with 1 minus p to the above equation, what you will get? 1 minus p here, right?
Yes.
So I'm writing that 1 minus p here, just below to this, because to solve the further. Then if you will multiply 1 minus p in the above equation, what you will get? 2 times 1 minus p whole square. Would you agree with me?
Yes, sir. Yes, sir.
Yes,
Then 3 times 1 minus p whole cube. Yes or no?
Yes.
Now
Yes,
what I will do now? I'm just I will subtract this equation from equation 1 to equation 2. So s minus 1 minus p times s. Okay, then what you will get? 1 plus 2 minus this thing, you will get 1 minus p, 3 minus 2, 1 minus p square, plus 4 minus 3, you will get 1 minus p cube and so on. Yes or no?
Yes, sir.
Yes.
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 Then what
Yes, sir.
you can see in the left hand side, I can take as such a common, I will get 1 minus 1 plus p. Are you getting
Yes,
this
sir.
one?
Yes,
Yes.
sir.
And the right hand side is what? It's just a something GP, right? So it's nothing but 1 plus r square plus r cube and so on. The answer will be summation of this will be 1 upon 1 minus r, because r is less than 1, right?
Yes.
Yes, sir.
Something you know.
P upon
So
1
for
minus
this case, instead of r, what we have? We have 1 minus p at the
One
right.
minus minus.
1 minus 1
1
minus p.
Minus
So
p.
1 minus 1 minus p. So here 1 will get cancelled out. So this is s into p equal to here again p only.
Yes.
So
Yes,
this
sir.
s will be what? 1 upon
P square.
p square. So you can see value of s is here 1 upon p square. So let me make this equation star. So from equation star, so what will be expectation of x? P into 1 upon p square, which is 1 upon p. The expectation of x in case of geometric random variable, when x represents the number of trials to get the first success, this will be 1 upon 2. Is this clear? Then similarly, you can proceed for other distribution. Okay, I'm not going into that much depth because we have to discuss other topics as well. Okay, and you can try. If not, you are not getting and you are getting any confusion to do the derivation, do let me know. I mean, you can basically tag us on Discord. I will solve and I will let you know. Okay, is this fine?
Okay, sir.
Okay, yeah.
Yes, sir.
Okay,
Yes,
so
sir.
there are yes. Okay, so next topic is expectation of function of random variable. Okay, I think that's one also is the easy one. Expectation of function of random. I'm writing RV for random variable. Okay, so let's say I have x1, x2, xn. These random variable from a probability mass function. Let's say f, and we have one function y, which I'm denoting as a y, which is any function of these random variables. Okay, then how to calculate the expectation in that? This is function of your xi's. Okay, then how will you proceed? So expectation of y is nothing but summation over y into probability that y equal to y. That's all. So what is the y basically? This is function of x. So let me say, if let's say x square is the one of the function. Yes or no? X square will be function or not?
Yes, sir.
Yes, sir.
If you want to calculate expectation of x square, then can I say x square into probability that x equal to x?
Yes.
Yes.
Okay, you can proceed like that. Okay.
Yes.
So
Sir,
let me take very simple example. Yes.
so this x equal to x square होगा ना अंदर?
No. So probability will be same, right? Probability can't change. So here what you are saying, let's say x is taking, okay, let me explain here. X is taking minus 1, 0, 1. So let's say y, x is taking minus 1, 0 and 1. Then what is the probability for each values? If this is the distributive form, 1 by 3.
1 by 3.
Yes.
So I'm writing here, so 1 by 3, right? So 1 by 3, 1 by 3, 1 by 3. So if you say y equal to x square, that means what? You are just squaring the values, right? Probability will not change. Okay.
Yes.
Yes, sir. Yes, sir.
Yes, sir.
So here basically, okay, let me rephrase again. So here what you will do, you can proceed in two ways. First of all, you can do like this, or else if you want to do, you can substitute the value of y and corresponding probabilities of y. So here if you see, what are the possible values of y you are getting? 0 and 1 only, right? Two things,
Yes, sir.
right? Because this will give you 1, this will give you 0, this will give, okay, when you are getting 1, sorry, 0, to get the 0, probability is 1 by
1 by 3.
to getting 1,
2 by
2
3.
by
2 by 3.
1 by 3 plus 1 by 3, which is 2 by 3. So there is two approach. First one, I can calculate the expectation of y, which will be summation of y into probability of y equal to y. That will give me 0 into 1 by 3 plus 1 into 2 by 3, which is 2 by 3, right?
Yes, sir. Yes,
Another
sir.
one is, it's a x follows uniform minus 1, 0, 1, and you have to calculate the expectation of x square. Okay, then how you can proceed? This will give you summation of x square, this one, and probability cannot change, right? So what is the x square basically? Minus 1 square into 1 by 3 plus 0 square into 1 by 3 plus 1 square into 1 by 3. You can see again you are getting the same thing. This will give you 0, this will be 1 by 3, 1 by 3, 2 by 3. Okay, so in both way you will get the same answer. Okay, whether you are writing a function here and corresponding probabilities of the original variable, or else you can find the all the corresponding respective values as well as the probabilities, and then you can calculate the expectation. Is this clear?
Yes, sir.
Yes, sir.
Yeah. Now there are something properties of expectation of properties of expectations. Okay, that will help you to solve some questions. Okay, if you are going to attempt. So
So
what is the
probability of y is equal to probability of function of y.
probability of y? No, so probability, actually see here you can find the probability of y means what? So first of all you have to find the what are the possible values your y will take, right? Okay, then from here only you can find the, okay, so let's say you here you can apply very basic things. So suppose I'm saying y is taking value 1, then from where y is taking value 1, and in which case y can get 1 when x is minus 1 and plus x is 1, right?
Yes, sir.
In these two scenario only y will take value 1, right? And what is the probability x will take minus 1? 1 by 3. And what is the probability x will take value 1? 1 by 3, which is 2 by 3. Okay.
Yes, sir.
So what are the properties of expectation? So first of all, expectation of any constant is same as that constant. Okay. And next is if you are adding a constant and to a random variable and you want to calculate the expectation, then this will be basically expectation of c plus expectation of x, and we know expectation of constant is that constant only, then it will be c plus expectation of x. Okay, then expectation of c times of x is nothing but c times of expectation of x. Okay, I'm not deriving. Do you need the derivation or is this fine? Basically, you can apply the formula, it will give you the answer within a second. Okay,
Fine, sir.
okay. Then expectation of x plus y, if you have two random variable, then it will be equal to expectation of x plus expectation of y. But this is okay, I will explain in case of variance. Okay, and if you have expectation of, let's say, a times of x plus b times of y, then it will be expectation of a times of x plus expectation of b times of y. By using the third property, you can see what I can write: a times expectation of x plus b times of expectation of y, where a and b are constant. Okay, and one more thing, expectation of x into y, this will be equal to expectation of x into expectation of y if this will be true only if x and y are independent. Okay, while in case of addition there was no condition, but if you want to find this expectation of x into y equal to expectation of x into expectation of y, this will be true when x and y are independent only. Okay, you cannot write when x and y are dependent and you wrote expectation of x into y equal to expectation of x into expectation of y. Okay, all right, any doubt?
Yes, sir.
I mean, clear or doubt?
Clear, sir.
No doubt, sir. No doubt.
Yeah.
Please go
So
ahead.
next topic is variance. Okay, so can
Sir,
you tell?
one thing, in last scenario, x and y, we use this property in independent case. But suppose multiplication rule is applied, but dependent case, then how to proceed?
Which multiplication rule? This one?
This type of
Oh,
rule.
that will be discussed. Don't worry, don't worry. We'll
Okay.
come to that. Okay, yeah.
Okay.
Yeah.
Sir, just a second. Can you just go up? So basically, in expectation of x plus y, it doesn't matter.
No,
if
it doesn't
the-
matter. Correct.
Okay, okay. Only
So
for
actually,
EXY it matters, right?
yes. So actually, you can proceed like this. So this is how you can proceed. So basically, whatever inside is there, you can write this one into probability that x equal to x in comma y
Right.
equal to y. Okay. This is something you can proceed. Okay.
Okay, okay, okay.
Okay. And you see, this is one of the property also, right? So there is something smartest approach also. Okay, I will come to that. Don't worry. So like if in the question it is mentioned if x and y are independent, or let's say, then you have to calculate the expectation of x into y. Then good way is to start with expectation of x into expectation of y, because anyway, if x and y are independent, then multiplication of these two values will give you this one, because it will save you somewhat time, right? Because in this case, what you have to do, you have to consider all the possible values of x and y. Let's say you have 3 cross 3 table, right? In that case, what you have to do, let's say 0 1 2, x is taking and y is taking 0 1 2. You have to see all the possible pairs of x and y and all the joint probability, and then you have to multiply, right? And
Right.
suppose you know the marginals, and then I mean it will save you somewhat time. Okay. Now, what's the role of variance? Anyone, any thought? Why you are thinking?
May I?
Yeah, please go ahead.
Sir, the basic problem with the expectation is that it is basically the measure of central tendency. So if we it can be a scenario that two random variable can have a same expectation, which can force us to think that both random variable are same, but they don't. So to encounter this, we actually introduce variance, which actually show us how much a random variable can elements of random variable can differ from their mean value.
Correct. Very good. Yeah. Anybody else?
Yes, sir. It is measurement of dispersion, sir.
Okay. Very good. Anybody else? Would you
Measure
like to
of dispersion from the average or mean value.
Okay. Correct. Okay. Yeah. All right. So Actually, I will take one example. When I think Kunal explained, and that's correct, and what others said, that's also correct. I will take example. Maybe that will give you idea. Suppose I'm saying, there is. I took one example. Suppose there is a university A and university B. Okay, and you have a data of, let's say, placement package in university A. Let's say uh, 10 lakh. Okay, I will write something very small values. Let me write 1, 2, 3, 4, and 5. So all are in 10 lakh. Okay. Suppose this means 1 means 10 lakh, 2, 20, 3, 30, 4, 40 lakh, 5, 50 lakh. Okay. In university B, there you have data of 5 students and all are, let's say, 30 lakh. Okay. In 10 lakhs unit. Okay. Now my question is, what is the average here?
30 lakhs.
30 lakhs.
Basically 3 for this. Yeah, 30 lakhs. Okay. In this case, average
3.
3.
So if you see, if you want to explain with the average only, right? So you will say on an average in both university placements are same, right? Correct. But in reality, both are same, or there is variability in the data?
Variability.
There is a variability, right? To identify, to overcome this issue, so variance comes into the picture. Okay. Then how to compute the variance actually? So variance of a random variable is nothing but you will do. Yes, average is sensitive to outliers on. Correct. So variance is nothing but it's expectation of x minus mu whole square. So mu is nothing but expectation of x. So this is what you are doing here basically. On an average, you are taking the difference of random variable from its average, and you are taking the squared difference. Okay. Why it's a squared only? Why not absolute? That we will discuss later. But squared is something I can say. Okay, it should be something like this only also, right? But if you will do, you will get this as a 0. Okay, you can try. Okay, you will take absolute, then in that case there is not something. Okay, I will give you a hint. You can search on it and you can basically work on it and let me know. So there is something called
Isn't it something, sir,
kind
like
of
in maths when
weightage,
we
or you can say penalty kind of thing. Okay, that's why we are taking
in maths when we studied about some squared error, something like that. Isn't it something like
that's
that?
fine, that's fine. Okay. So this, okay, let me tell you this. Okay, this is one of the formula. Okay, and another formula is I will tell you. I will derive this one. So what is the a minus b whole square? It will be expectation of x square plus mu square minus 2 mu x. Can I write?
Yes.
If I can
Yes,
take
sir.
expectation inside, expectation of x square plus expectation of mu square minus 2 mu expectation of x, because 2 mu are constant. Mu square will be again constant, then expectation of x square plus mu square minus 2 mu. What is the expectation of x? Mu only.
Yes.
Yes.
So this will be expectation of x square plus mu square minus 2 mu square. It will be expectation of x square minus mu square. Yes or no? So basically variance of x is nothing but expectation of x square. We know mu is nothing but expectation of x whole square. So this is the another formula. So this is actually even I use more frequently because this is it seems easy to me, and for most of the people feel it's easy, because here what you have to do, suppose you calculated expectation of x as summation of x into probability x equal to x, and within the time you can calculate expectation of x square as summation of x square into probability that x equal to x. Okay, and you can start finding the answer. So basically I will take that example. Okay, so everyone has pen and paper, yes or no?
Yes, sir.
Yes.
So can you apply the variance formula, which is expectation of x square minus expectation of x whole square for this example, and let me know what is the answer you are getting.
Sir, is probability 1/3?
Can you let me know what should be the probability? So this is something, if you are given in the exam, then no one is going to tell you. So this is discrete uniform, right? So this probability will be 1/3. Your answer is correct, but I'm just okay.
So 2 by 3.
2 by 3, sir.
Okay.
2 by 3.
I don't know answer. Actually, I wrote the example directly, but yeah, I will solve. So if 2 by 3 is majority, I think then it's correct. Okay, so how will you proceed expectation of x square? First of all, x is taking value -1, 0, 1 with the probabilities 1 by 3, 1 by 3, 1 by 3. Expectation of x we calculated in the previous example how much? 2 by 3?
2 by 3.
Sorry,
2
it's
by
0. Expectation of x is 0, right? Because
Yes, sir.
expectation of
Yes.
x is summation of x into probability of x equal to x, right? Then it will be -1 into 1 by 3 plus 0 into 1 by 3 plus 1 into 1 by 3. So minus 0, 1, basically 0, right? Expectation of x square, that means what? I can proceed directly summation of x square into corresponding probabilities, right? So it will be -1 square into
Yes, sir.
1 by 3 plus 0 square into 1 by 3 plus 1 square into 1 by 3. So this will be 2 by 3, and variance of x is nothing but expectation of x square, which is 2 by 3 minus expectation of x whole square, that is 0 square, that is 2 by 3 only. Is this clear?
Yes, sir.
Yes.
Yes, sir.
Great. Now next topic is called standard deviation. Okay. So standard deviation of a random variable is nothing but it's the square root of variance of x. Now my question is, if you have already variance of x, then what is the importance of taking square root, or what's the importance of introducing the standard deviation?
The unit.
So,
Correct.
sir, if we took the square root of variance, it will give the more precise answer.
What do you mean by more precise? In terms of what?
A more precise value, actually.
No, okay.
Random variable.
Let me rephrase the question. Suppose I'm saying I got variance is 4, and you are saying standard deviation is 2. Then what do you mean by more precise? Decreasing terms, increasing? I mean, in terms of what? Yeah, go ahead.
I'm not
Don't
getting
think.
Data is how much deviating from central tendency.
No, same thing variance is saying, right?
Sir, we can get a lesser.
Variance saying the variability between the data.
Okay. Can you see this formula? So, okay, suppose I'm saying you have a thing,
It makes the
something which
unit
is
same, unit of measure same basically.
correct. Units are same, right? So, what is the importance of units are same? Then, suppose you have a data x is representing age. Okay, let's say age in years, for example. Then you will calculate expectation of x that will give you, let's say, 42 year, for example, hypothetically. Okay. But if you calculate the variance of x, let's say you are getting 16 year square. Okay. Then if you focus on the units, so here units is the square of the original data, right? Units of the original data. But if I will take the standard deviation of x, I will take the square root of 16 years square. What I will get? 4 years. So units of this will be same as units of original data.
Yes.
Then it will help you to interpret the result, to do the comparison of do the comparison of the result with the original data. Okay. All right.
Yes, sir. Yes, sir.
Okay, sir.
Yeah,
Now,
actually, that's my point. Basically, I was not able to describe
okay,
that.
no problem,
It's
no problem.
the
So
point.
yeah,
Basically, it gives the more precise answer.
yeah, correct.
Yes, sir.
Very good. So the thing, whatever you feel, right? So just try to say, don't worry. There is no need to worry about whether it's going to wrong or correct. If you will say something, okay, whether it's wrong, then we are there, right? So we will say, we will explain you whether at what point you are making mistake, or this is something you should be careful. Okay. So do
Yes,
not
yes,
worry
yes.
about those kind. Okay, whatever the things you are feeling, just try to explain. Okay, because see, if you will type variance on Google, you will get lots of information. The thing which you should understand, whether concept is clear in your mind or not. Information is everywhere, right? So you can find from any source. The thing is, it should be clear in your mind. I mean, you should be able to explain to someone. Okay. Okay, so there are properties of variance. So as I mean, there were some properties in case of expectation also. So variance of a constant is 0. Would you agree with me? So you can think
Yes.
like this. So variance of x is what? Expectation of x minus mu whole square, right? Then variance of a constant will be expectation of x minus expectation of this will be basically this will be c minus c. This is
C minus C, yeah, it will be
so
0. Yes.
variability for a constant is 0. Okay. Then second is variance of a times x. A is a constant. It will be a square variance of x. Okay. Should I do the derivation or it's fine? Okay, let me do it for this one. So okay, so that it should be clear. What is the variance of x? Expectation of x square minus expectation of x whole square, right? Then variance of a times x will be what? Expectation of a square x square minus expectation of ax whole square. Would you agree with me?
Yes.
Then here a square will be outside because expectation of c times of x, any constant, will be outside, right? And here if you see a you can take outside, then it will be expectation of a times expectation of whole square. Yes or no?
Yes, sir.
A square expectation of x square minus it will be a square expectation of
Yes,
x
sir.
whole square. A square I can take common from here. What I will get? Expectation of x square minus expectation of x whole square. Would you agree with me? A
Yes, sir.
square, what
Yes,
is
sir.
this? This is
Variance.
variance of.
Variance.
So variance of a times of x will be a square variance of x. Clear? Then similarly, if you want to find the standard deviation of a times of x, then what
A
should I write?
into standard deviation.
Correct. A into standard deviation of x. Okay. Variance of x plus a.
Yes, sir.
Variance of x plus a.
Variance of x. No, sir.
No,
It
sir,
got
only X.
cancelled.
X.
Okay. Yes. Because a will get cancelled out, right? Because here you
Yes.
will substitute, it will be x plus a minus mu minus a will again get cancelled out. Okay. Basically, you have learned in statistics 1 course also, adding or subtracting something, a constant will not affect the variability.
Yes.
So standard deviation of x plus a again will be standard deviation of x.
Yes, sir.
Yes, sir.
Now the something you have to be careful. In case of expectation of x plus y was expectation of x plus expectation of y in any situations, right? But does this true in case of variance also or not? So answer is no, it will not be equal to always. I mean, it will not be, means you cannot write variance of x plus y equal to variance of x plus variance of y always. People make mistake because they think in case of expectation is then in case of variance will be true. No, this is equal to, but there is one condition. If x and y are independent. Okay, I will tell you the reason, because reason is variance of x plus y. It's the formula for this is variance of x. This is same as variance of y plus 2 times of covariance of y. Then if you are saying x and y are independent, then in case covariance is 0. Basically, I will discuss in a minute. Covariance tells us you the linear association between two random variables. If you are saying x and y are independent, that means those two random variables are not correlated. Are not correlated means covariance is 0. Covariance is 0 means variance of x plus y will be variance of x plus variance of y if x and y are independent. Is this clear?
Yes, sir.
Yes, sir.
Okay. Now,
sir, one thing here in our you wrote here a square into variance of x, and above can we write it like this: a square ex square, because ex whole square will be 0.
ex of how you will say e of x square will be 0?
No, in above we I think calculated ex will be 0. The probability of e of x.
No. Okay, you are saying in for this particular example.
Okay, sir.
Okay, it was for that particular example. Okay, it's not true for. So these all things I wrote in general. Okay.
Okay, sir.
Yeah. Okay, this is clear. If you want to calculate a standard deviation of x plus y, can you write standard deviation of x plus standard deviation of y? Should I write like this?
Root is there.
Root under variance of x plus y.
Correct. This is not, you cannot write, because so this will be variance, square root of variance of x plus y. Okay. Now, okay, so next topic is called covariance. Okay. So basically, covariance tells you the linear. What's this? I think there is some echo. I think you have joined with two devices, maybe. Okay, please.
Sir, sir, in the above property, the upper one, can you please?
Yeah, tell me. I'm writing something. Yeah, go ahead.
Yeah, it's a addition, standard deviation of x plus y, sir, right? And here variance under root of variance x plus y. Isn't it under root of variance x into under root of variance of y?
No.
How is this calculated? Yeah, please.
Okay, you are saying under root of variance of x into variance of y.
No, like how we get this expression variance of x plus y under root.
See, what is this standard deviation of x? How will you define?
Yeah, under root of standard deviation of x.
Under root of variance of x.
Yeah. Yes.
Instead of x, I am saying I have x plus y. I will calculate the variance for x plus y. I will take the square root. That's all. At the place of x, you can take x plus y. You just define x plus y as a z. Just I'm saying z as a x plus y. Then I can calculate standard deviation of z as square root of variance of z. Clear?
Okay, sir. Okay, got this one.
So covariance tells us you the linear association between random variable x and y. How to proceed? How to calculate covariance? So formula for to calculate covariance between x and y is nothing but expectation of x minus expectation of x into y minus expectation of y. Okay, so basically this is deviation of x from its expected value. This is deviation of random variable y from its expected value. If you will solve this, right, like I did in case of variance, okay, I'm not going to do. If you are interested, try. And if you solve this, so rather than x minus mu only, there is y minus expectation of y also, right, into. Then if you will solve this, so you will get covariance of x comma y as expectation of x into y minus expectation of x into expectation of y. Okay, so actually this is the another formula. You can try this one, or you can try derivation. Do let me know if you are getting difficulty at any point. Okay, so okay, one more thing you can observe here. If I will say covariance between x comma x, then what you will get? Expectation of x square minus expectation of x into expectation of x. So this will be expectation of x square minus expectation of x whole square.
Yes.
What is this?
Variance.
Okay, now you can see, right? One observation from here. So covariance between x comma x is nothing but variance of x only. Correct? So one more thing, you have to observe here basically. So if x, I told you, right, x and y are independent. Okay, so x and y are independent means there is no dependency, right? Then covariance will be 0 or not? If you are saying
yes, sir.
two things are independent, that means there is no correlation, right? They are not correlated at all. So covariance between x comma y is 0. That means expectation of x into y minus expectation of x into expectation of y will be 0. Would you agree with me?
Yes, sir.
If this is the case, can I say expectation of x into y is same as expectation of x into expectation of y? And I wrote this formula, this property in case of expectation of x into y equal to expectation of x into expectation of y when if x and y are independent. And why it was true? Reason is this, because if you are saying x and y are independent, that means covariance is 0. Covariance 0, this will imply this part, and this means this part. Is this clear?
Sir, because of independence, that's why we are subtracting the product of expectation of x and y from.
No, it's not like you are subtracting. Basically, this is a formula of covariance. Okay, just try to think like this. Okay, so this is the formula of covariance. You are saying x and y are independent. That means covariance will be 0. Covariance will be 0 means this part will be 0. Yes or no? This formula, right? This is 0, and if you transfer to the right hand side, you will get this. Okay.
Yes, because there is no intersection part. That's why it will become
correct.
0.
So one more thing, intersection means you cannot say there is no relation. Intersection is different thing. So if you say, okay, can you just let me know if I'm saying if covariance between x comma y is 0, okay, does this imply x and y are independent? Can I say?
Yes, sir.
Yes.
Yes, sir.
How many of you are saying yes? Okay. Okay. How many of you saying no, or everyone is saying yes? No one is saying no. So one hint, this will be you are saying covariance comma x comma y is 0, covariance between x and y is 0, and this will imply x and y are independent. I will say not always. Now can you think a bit why?
There may be any
Sir, can you
mathematical.
please show the above formula for covariance?
Sir,
Yes,
there
sir.
might be no linear relationship.
Correct.
Or
Correct.
0.
Actually, see, covariance will give you the linear association between x and y, right?
Yeah,
And
sir.
and if you are saying covariance is 0, that means there is no linear relationship, right, between x and y. But there can be another type of relationship, right? So for example, I can say y is related as a x square, and covariance between x comma y is 0. But in that case, you cannot say x and y are independent. So independent means there is no relation at all, right? But there is some dependency. Yes or no?
Yes.
Are you getting the difference, right? So if you are saying x and y are independent, then covariance will be 0 for safe side, because independent means there is no relation at all, means there is no linear, no quadratic, and anything. But if you are saying if covariance is 0, then can you comment and x and y are independent? Not always. It may be, it may not be, because if sometimes suppose y is related as x square and covariance you can get as a 0. Is this clear?
Excuse me, sir.
Yes, sir.
Sir, can you please explain it again? Actually, I'm getting confused. That's all.
See, first of all, what do you mean by independence?
Means
Sir, can
one.
you explain linear relationship?
What is this x plus 2, x plus y, x plus 3? This is this kind of linear, right? Means mx plus c, right? Slope and
Yes.
intercept. Okay. If you are saying x square, is this linear? No. For x square, you will get some
It's
quadratic curve,
quadratic.
right?
Yeah.
Okay. So independent means what? If you see the word independent means there is no dependency at all, right? So independence means there is no relation at all. So no relation at all means I will sure I can say surely covariance will be 0. See, if I'm saying x and y are not related at all, that means there is no linear relationship exists, right?
May I say something?
Yeah, go ahead, please.
So, but the moment, like if we take x and x square, say for example,
huh.
we are already making y dependent on x, right?
Correct.
Okay. In this case, there may not be any linear relationship, but there is some
But
kind of
covariance will be 0. Covariance can be 0, right?
Will be 0.
Okay. So basically, if you are saying independent, that means covariance will be 0. Independent means there is no linear relation. I mean, there is no relation at all. But if you are saying, if you are focusing here, if you are saying covariance is 0, then can you comment on x and y are independent? Not always, because covariance is 0. This will give you just information like your x and y are not linearly related. There might be another kind of relationship. They like it's possible they are there is a quadratic relationship between those two, right? Okay.
Yes, sir. Yes, sir. Yes, sir.
All right.
Yes, now clear, sir.
So there are some properties as usual. So properties are, so as I have shown you, covariance between x comma x is nothing but variance of x, right? So these properties, all these properties in your mind, right? So this will save you some time. Also, covariance x comma y equal to covariance of y comma x, yes or no? Because it will just interchange this, right? Yx, right?
Yes.
And another thing is covariance between let's say x comma, I will say there is ay plus b times of g or z. So it will be covariance x comma ay plus covariance x comma bz, and since constant I can take outside a times covariance of x comma y plus b times covariance of x comma z. Okay, so how to calculate the covariance and all, I will take example. Okay, so let me take that example. So I think let's say this is xy. For the safe side, suppose this is 0 1 2. Yes,
इन सबका डेरिवेशन पता होना जरूरी है क्या?
No. But if you are interested, I would suggest go through that, because something you should be careful. I mean, it's something like that. No, pata hona chahiye. That's all. So, but in exam, it's not like we will give you to derive, but it should be clear. I mean, from basically history should be clear.
Because in some questions we have to apply some derivations. Sometimes, sir, I have seen.
Yeah, sometimes, yeah. In week 2 and all, in week 1 and all, week 1 and week 2, right? You can see Poisson given binomial and
Poisson, yes, sir.
yeah, those things should be in your mind. Yeah, those things should be in your mind. Okay, that is something not derivation, but at least result should be in your mind. For what condition, if given this, let's say given Poisson n equal to n, then what will be the distribution of this? So those things should be in your mind. Okay, because that will help you in your exam. Okay,
is there some kind of formula sheet, something that's
formula sheet will be given to you, but all the results we cannot provide, right? Basic formula sheet will be there. Okay. I will show the formula sheet also, don't worry. What are the things will be there. I mean, do not worry, all the PMF, expectation, variance of all the discrete, all the continuous variables, all those things will be there. That's something you should take care on your own side, right? Let's say all the results of those things, right? I mean, let's say Poisson is given to you. I mean, if I can recall from it's in week 1, right? If basically n is, I mean, suppose capital N follows the Poisson distribution, okay? And I mean, there is something you have to toss a coin n many number times, right? Then x given n equal to 1 will be binomial, and marginal will be Poisson, right? Marginal of x. So that is something you have to keep in your mind. Okay.
Sir,
okay, let's focus there.
Then you guys can make a good sheet of derivation forms of something, sir. Then it will be more helpful, sir.
Okay. Yes. So one thing I can say you, we can give everything. That's not a problem at all. So already we have provided most of the things. So see, sometimes suppose I'm taking this as right. Sometimes I'm leaving the things on you so that you can try on your. Okay, suppose I didn't, for example, I didn't derive this part. Okay, for example, I didn't take any example. Why? Because you can think example, and this is your side job. I mean, just think and try it out. If you are not getting, let us know. We are there.
Yes,
Okay.
sir. Because the time is limited, that's why. Otherwise, we can do.
See, one thing I will say again. There's something which you have to manage. That is time. Okay. So, but yeah, will anyway. So you can first of all the short notes you can find from the supplementary content, right? Have you seen
Yes,
those?
sir. I have already found.
Yeah. So you can refer those things. Okay. Let me show you the formula sheet. Accordingly, you can prepare for exam.
Yes, sir, the weekly notes portion.
Yeah, weekly notes is will anyways is going to helpful here. So weekly notes you can find from the portal. Okay. So this is something there is no need to if you want to do the quickly revision, you can go through that. Okay, this is the formula file for your quiz one. Okay. So all the discrete, you can see random variables, PMF, CDF expectation. Don't worry whether it's in your mind or not. Okay. If it's in your mind, that will save you time. I'm saying there is no need to scroll up, scroll down during the examination. Okay. But if you are unable to recall, if you don't to remember too many things, don't worry. But you should be identify. Okay. So these are things will be given to you. All the continuous distribution, Markov inequality, Ceviche inequality. So this is for quiz one only. Okay. For quiz two, another formulas we will provide. Let's say till weak law of large number and another
So
inequality.
ये
Okay.
कहाँ मिलेगा, sir?
First of all, you will find you with your question paper in exam. Okay. But I will share on the portal along with mock. Okay.
Yes, sir.
Okay. So let's
Sir,
try
sir, February 23rd exam, 4 week or 5 weeks, sir, because
4
it is
week,
all
4 week, 4 week.
because six weeks will be over by then, no? Six
Yeah,
what
that is something. See, content will be released every time. I mean, on every week, right? That is something you have to manage. Okay, because
content and graded assignment. This one.
everything you have to manage, because once quiz one will be there, then there is less time for quiz two also, right? Then it's not something once week 4 will be finished, then you will give quiz one, then we will start week 5. No. So every week we will release the content. For quiz one, syllabus is till week 4. Then you have to prepare till week 4 for quiz one. Okay. So this is marginal of Fy of y. This is marginal of Fx of x. So my question is, you have to calculate the covariance between x and y. So how will you proceed? Basically, covariance between x comma y is nothing but we know the formula expectation of x into y minus expectation of x into expectation of y. Yes or no? Then how will you proceed expectation of x into y? Basically, so expectation of x into y, this nothing but summation over x values of x into y and joint probabilities. Yes or no?
Yes.
First, let's try to find the marginal. What will be marginal here? 3 by 9.
3 by 9.
Yeah.
This is
6 by 9.
6 by 9.
6 by 9.
Yeah. 1 by 9. 3 by 9.
3 by 9.
5.
Total is 1. Okay, the values that I took correct. Okay, thanks. Great. Okay, so how will you proceed here? Expectation of x into y, that means basically 0 into corresponding probabilities, because this 0 by 9 will give you the probability at x equal to 0 and y equal to 0. Would you agree with me?
Yes, sir.
So this will be
Yes, sir.
0 into 0 by 9. Yes.
Yes.
And this 0 into 1 by 9. So this is something I'm writing because you should know how to calculate expectation x into y. Then 0 into 2 by 9. Are you getting?
Yes, sir.
The next will be 1 into 0 into 1 by 9. 1 into 0 into 1 by 9 plus 1 into 2 by 9. Everyone is with me now?
Sir, 1 into 1, no?
1 into, sir.
Sorry, 1 into 1. Yeah, thanks. Then 1 into 2 into 3 by 9.
3 by 9. Correct.
So you can see this will be 0, 0, 0, 0, 2, 6, right? So 2 and 6, 7, right? 7 by 9.
8 by 9.
Sorry. 6 plus 2, yeah, correct. 8 by 9. And how will you proceed for expectation of x? So this is summation of x into probability that x equal to x. Then in that case, what you have to do? X, that is 0 into 1 by 9. Let me use some other color. Let me blue. So 0 into 1 by 9, 1 into 3 by 9, 2 into 5 by 9. So that means I'm writing 0 plus 1 into 3 by 9 plus 2 into 5 by 9. So that means 13 by 9.
Correct.
And how will you proceed for expectation of y? Summation of y into marginal probabilities for y. Let me use some other color. Let's say some.
Sir, can I know why are we using marginal probabilities?
How will you calculate expectation of x? To calculate the expectation of x, you need probability of x equal to x, right?
Yes, sir.
Or probability of what is probability of y? Probability of y equal to this is marginal one, right?
Yes, sir. Yeah, thank you.
Yeah. So it will be 0 into 3 by 9 plus 1 into 6 by 9, correct? Plus 0 into 1 into 6 by 9. This is 6 by 9. So covariance between x comma y will be how much? Expectation of x into y minus expectation of x into expectation of y. So this is 8 by 9 minus 13 by 9 into 6 by 9. So this will be basically whatever
Minus
the value. Minus
6 by 81.
6 by 81.
Okay, I'm assuming this is the correct. Okay. Now you got the idea how will you calculate covariance?
Yes.
Okay, great. Let me introduce next topic called correlation. My question is to all of you, those who have covered or anyway, so you are done with stats 1. So I would like to hear from you, what is the role of covariance? Why? What's the big importance? Any thought? Whatever you feel, you can let me know.
So it gives the behavior of one variable with respect to the another variable. Like
what do you mean by behavior?
Like whether it is, say for example, if one variable is going to one side, for example, it's going from 0 to 1, and another variable is going from 0 to 2. So like, since both are increasing, so basically
it established
the
relationship.
relationship of the change in both the variables.
Mother, two variables are related together. That is something we can get from covariance also, right? Covariance gives you the linear association. I mean, suppose you can find, you can draw a graph. This is x, this is y. You can find the graph like this. Then in this case, covariance will be positive, right? Yes or no? So my question is, what is the role of covariance, correlation?
If one variable is related to the variable, then
how strong is the
strength of linear association.
Correct. How strong connectivity? What is the strength? So strength is the correct word. So basically, if you see, covariance is something what? Covariance here we got in minus, right? Covariance between two variables, you can get minus 150, right? Covariance between two variables, you can get minus 50. Covariance between two variables, you can get 0. Covariance between two variables, you can get 150. Covariance between two variables, you can get 90 something else. But what kind of interpretation you can do from here? You can simply say x and y are negatively correlated. There is x and y are positively linearly related, something, right? Can you comment which one is strong? Strong means, can you say this is the strongly negatively related or this is a strongly positively related? Can you say?
So there is no scale in this covariance.
Correct. There is no upper limit, right? How you will comment which one is the highest, right? Are you getting my point? So for some data, maybe 9 is highest, for some data 100, but you can't comment, right?
Right.
Yes, sir.
Correlation is, first of all, is the unitless measure. How I will explain. Okay. And correlation, how you can define correlation between two random variables, this is rho, is nothing but covariance between x and y divided by standard deviation of x into standard deviation of y. Okay. And correlation lies between -1 and +1. So because of this, if rho is close to +1, you will say this is strongly linearly related. Okay. If rho is close to -1, you will say strongly, I mean, there is a negatively related. Okay. Negatively linearly related. Okay. Rho is 0 means there is no linear relationship. Okay. Why is the unitless measure? Suppose there x is, let's say, age, and let's say y is the weight of person. Okay. Then what will be the units in numerator part? Year into kilogram. Yes or no?
Yes, sir.
Because covariance is what? Expectation of x minus expectation of x into y minus expectation of y, right? And the standard deviation of x, again it will be give you the year into kilogram. It will get cancel out. Okay. Now it's clear. Okay. So if you want to calculate correlation, so you have to calculate covariance, standard deviation of x, standard deviation of y, and that will give you the. All right.
Yes, sir.
Okay. One more thing. How many of you covered all the lectures of week 4?
The
No?
week 4?
From week 3.
Sorry. Week 3.
Yeah. I've
Nothing.
Nothing. There are 7 lectures. How many of you covered at least 4?
Yes.
Okay.
Yes, I.
Less than 4? Okay. Okay.
Yes, they're mostly dependent on live classes.
Okay. Okay, just give me 2 minutes. I will connect my laptop with charging and I will be back. Okay.
Yes, sir.
Yeah. Just give. Okay. So there is, we will discuss the next thing, which is called there. I mean, there is some inequalities. Okay. What are those inequalities? We will try to discuss. Okay. So first one is Markov inequality. Okay. What is this Markov inequality basically? So scenario is you have a random variable x which is I mean, so since we are discussing about discrete, so let's say x be a discrete random variable. Okay. The condition is this is taking non-negative values only. Okay. Non-negative values. Along with this, expectation of x is, let's say, mu. The scenario is, what is the Markov inequality? So Markov inequality says probability that x is greater or equal to c. C is a constant less or equal to mu by c, and c is the non-negative constant also. I mean, c cannot be less than 0. Okay. The question is, okay, now this is the Markov inequality. So my question is, okay, this mu is what? Expectation of x. So you can write here expectation of x divided by c also. That both are correct. Okay, just difference of notation. So just suppose the first time someone is giving you this thing, okay, and question is, what is the role of this? I mean, what is something you can interpret from this, and can you think something what should be the reason behind this using the inequality? Anyone? Suppose very first time you are saying, and what should be the reason behind this? What can be the reason basically?
So what is CS?
C is a constant, non-negative constant.
So for finding upper bound,
Okay, correct.
Or we can use an inequality for comparison of the both the values.
What do you mean by both values?
Like the left hand and right hand side, how they are deviate from each other.
Okay. Anybody else?
We can checking the inequality between constant and a given value variable. Like this.
Correct,
So
correct.
we can compare with.
Yeah. Okay. Yeah. Let me explain. Let me know if you are getting. So first of all, this is upper bound, right? So what do you mean by upper bound? So upper bound means this probability cannot exceed this value. This probability will always be less than or equal to this entry. Okay, this entity actually. Okay, so this is upper bound. Okay, upper bound means this probability cannot exceed this. First, what is the useful of this scenario? Basically, okay, let me take one example, then I will explain you why. So suppose example is, suppose I'm saying x follows binomial 5 comma half. Okay, then my question is, if you have to calculate probability that x is greater or equal to 4, what you will do? Tell me.
P of 1.
P of, no, how, why 1? P of x equal to 4 plus P of x equal to 5. That's all.
Yes.
Basically, if you will apply, then you will get 5c4 half raised power 5, then 5c5 half raised power 5. Would you agree with me? I'm applying the formula. Let's say whatever the values. Okay, so what is the value of 5c4?
5.
5. And 5c1 is, so 5 divided by 32 plus 1 divided by 32, right?
Yes.
So this will be 6 by 32. Anyone can calculate 6 by 32?
Yes, it's correct, sir.
No, I mean
3 by
in decimal.
16. 3 by 16.
3 by 16.
3 by?
3 by 16.
I mean decimal. Okay, let me calculate.
0.1875.
Okay. So okay, correct. Now my question is, okay, suppose on this same thing, if you will apply the Markov inequality, what you will get? Probability that x is greater or equal to 4. So what is Markov inequality? X is greater or equal to c, less or equal to mu by c, right? What is the mu? Expectation of x. So in case of binomial, what will be the expectation? N into
NP.
p, 5 into
Yes.
1 by 2, that is 2.5.
Correct.
right? So it will be mu by C, that is 2.5 divided by C. What is C?
4.
Right? What is the value of 2.4 2.5 divided by 4?
0.625.
0.625. So one thing you can interpret from here, this probability will always be less than or equal to 0.625. So if you will calculate here exact probability, this is the exact probability, right? By you are getting exact value, right?
Yes.
Yes, sir.
So it can't exceed this value. So you can see this 0.1875 is less than this upper bound.
Right.
Right. Now, what is the importance of this? First of all, I will explain you. The thing is, here you had information about, okay, let me say, suppose, let me take another example. Suppose X representing the number of products, okay, which produces in a company in a week, okay, and average is, let's say, 50 and variance is, let's say, 16. Can you calculate the probability that in that particular week there will be at least let's say 20, or let's say at least 25, I mean there will be at least 25 products will produce in that particular week. Is the question clear? Question is, X represent the number of products which produces in a company in a week, okay, with average 50 and variance this part. This is the question. My question is, you have to calculate probability that there will be at least 25 products production. Okay, basically 25 products will be produced basically. Okay, so that means X will be greater or equal to 25.
Right.
Right. Then what will the probability? Now, can you calculate exact probability here? Yes, no. Exact
Yes,
probability
sir.
means like
No,
this.
sir, we do not have PMS. No?
Correct, correct. You don't have any information about whether X is following any standard distribution or not, right?
Correct.
In that case, you cannot calculate the exact probability. Since you cannot calculate the exact probability, but you can find a bound, right? This probability cannot exceed the. So inequalities are more helpful in that scenario. Okay. So here it will be less or equal to expectation of X, that is 50 divided by C. C is 25. So probability, I think there is something wrong.
Sir, it will become P of X equals to 25. That's it, right?
No, actually here values we have to adjust. Actually, it shouldn't exceed 1 actually. Okay. So let's say some expectation of X, let's say some 10. Okay. Then 10 divided by 25. Okay. So just
yes, because sir, if anyways expectation will be 50, it will anyways produce 25, na?
Correct, correct. So this will be, let's say this will be 0.4 if I'm taking expectation as a 10. So what you can interpret, that probability will be at least, probability that X will be at least 25 is less than or equal to 0.4, but you cannot calculate the exact probability because you do not have any information about your random variable X, right? Suppose X is followed binomial, Poisson, or geometric, or else you can calculate the exact probability. Even you can apply the inequalities also. Is this clear?
So, sir, like in what, just wanted to understand, like in which kind of cases, like we use this thing, like in practical scenario.
Okay, so this is the practical scenario. Suppose I told you, right, X represents the number of items produces in a week, right? Okay. With, let's say, with average number and there is some variance. But and my question is, let's say someone asks you what is the probability that in a particular week there will be let's say more than 20 items will be produced. Now, how will you calculate? Okay, suppose X is binomial, then you will say, okay, 1 minus X is less or equal to 20 or something else. You can add the probability. Let's say in case of, suppose X is binomial, okay, and this maximum value is 25, then what you will do? You can add the probabilities, right?
Right.
Till 25, and you can calculate this is the exact probability. But in case of you don't know the distribution, then how will you proceed? You can find a bound only, right?
Okay.
Okay. The one thing you have to be careful, since X is discrete, right? Okay, so suppose if I'm saying because that is something in exam it might be checked. Suppose I'm saying x is more than 20, then what will be the value for Markov inequality? What you will write here?
0.6.
What will be here? Less or equal to what?
10 by 20.
10 by
20.
Everyone would agree with this part?
Yes, sir.
Yes.
Okay.
Yes, sir.
I'm writing the Markov inequality again. Just think a bit.
So equality is missing over here.
Correct. Because this is a
So
discrete.
10 by
Right?
21.
10 by 21 is the correct answer because this is a discrete, right? In case of discrete, equality matters. In case of continuous, equality doesn't matter, right? So if you are writing x is greater than 20, that means x is greater or equal to 21. This will be less or equal to 10 by 21. Okay? Since x is discrete, right? All right, clear?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
The next is, do you have session at 8 or?
Yes, sir. We
Yes,
have
sir.
session 8.
Yes, sir.
Yes.
Maths 2 session.
Okay. We'll try to finish. This is the last topic, which is Chebyshev inequality. Okay. If time allows, we will solve some question, or else we will discuss in the next session. Okay. Now, what is the Chebyshev inequality? First of all, again the same scenario. X is discrete random variable, and expectation of x is less than mu, and the variance of x is sigma square. These are just notation. So then, first inequality says probability that modulus of x minus mu, okay, greater or equal to k sigma, okay, this is less or equal to 1 by k square. Okay, so this is upper bound. Okay, one more thing, you can find the Chebyshev inequality with the help of Markov inequality. How? I will tell you. I will give you the hint. You can try. So let's. What is the Markov inequality? X is greater or equal to c, less or equal to mu by c, right?
Yes.
Suppose x is what? X was non-negative random variables, right? Which takes non-negative values, right? So if I will replace x as a x minus mu whole square, and c was non-negative, c as a k square x is sigma square. This is non-negative. This is non-negative. Would you agree with me?
Yes.
Then what else you can get? X minus mu whole square greater or equal to k square sigma square. What is this? Mu. Mu is expectation of x. Then here expectation of x minus mu whole square. Are you getting? Divide by c. So instead of c, we have k square sigma square. And this part, can I write this part as a modulus of x minus mu greater or equal to k sigma, less or equal to, what is this? Numerator part will give you the variance, right? Variance is expectation of x minus mu whole square, right?
Yes, sir.
Yes, sir.
Numerator part will be sigma square divided by k square sigma square. So sigma square will get cancelled out. So this will be probability that modulus of x minus mu greater or equal to k sigma less or equal to 1 by k square, which is this. Okay. So what is the role of here? So here you can see variance comes into the picture also, but in the Markov there is role of expectation, and here you can if you think about this inequality, let me write the inequality again. Probability that modulus of x minus mu greater or equal to k sigma less or equal to 1 by k square. So this will give you the probability. This will give you the bound. It will help you to find the bound basically. You can find in which scenario when you are interested to know how far is your x from mu. Okay, how much deviation is what is the probability that x will deviate from mu with some constant, that will in that case you will get it will depend whether you are interested to calculate the upper bound or lower bound. So second form for this inequality is probability that modulus of x minus mu, okay, less than k sigma greater or equal to 1 minus 1 by k square. So this is lower bound, right? So what do we mean by lower bound? So lower bound means we see this probability will always be equal to, will always be greater or equal to this quantity, right? So this is lower values, right? And this is, and this probability cannot exceed this value. This is upper bound. Okay, but which inequality you can use in which scenario? So let me explain you. First of all, sometimes it is clearly mentioned whether you have to calculate the upper bound or lower bound. Okay, let me solve this. So if you will expand this formula, probability that modulus of x minus mu greater or equal to k sigma less or equal to 1 by k square. To just okay, if this is the case, can I write x minus mu is greater or equal to k sigma, or x minus mu less or equal to minus k sigma? Would you agree with me?
Yes.
Yes.
This mod sign, right? If this is the case, can I write x is greater or equal to mu plus k sigma, or x is less or equal to mu minus k sigma? Would you agree with me?
Yes.
Yes, sir.
Right. So if you have any scenario, you have to calculate a bound such that your x is greater or equal to something or less or equal to something. In that case, you have to use this part. Okay. I will take example. Don't worry. Just wait for a second. Okay. Now, is this clear? Now, if you see the second formula in case of lower bound, probability that modulus of x minus mu less than k sigma greater or equal to 1 minus 1 by k square. Okay. Inside this bracket, can I write minus k sigma less than x minus mu less than k sigma greater or equal to 1 minus 1 by k square? Would you agree with me?
Yes.
Yes.
If this is the case, can I write mu minus k sigma less than x less than mu plus k sigma greater or equal to 1 minus 1 by k square?
Yes.
So this formula, lower bound formula, you can use when it is asking probability that x will lie between some value, right? Between two values, and you have to use the upper bound formula when it is asking x is greater than some quantity or less than or equal to some quantity. Is this two statement clear? I will take example and then explain you. Yes? No?
Yes.
No, sir.
Okay, are you not getting this? This is some value. This will give you some value because mu is constant, sigma is constant, k is constant. Okay, if you are asking, suppose question is you have been asked what is the probability that x will be greater or equal to some quantity or less or equal to some quantity, then you have to use this upper bound formula. Okay, if you have been asked your x, what is the probability that you have to calculate a bound on the probability that x is lies between two values. Okay, this value will be given to you, suppose, then you have to find the lower bound. Okay, let me take one example. Okay, suppose I'm saying x is a discrete random variable with expectation is less than 50 and variance is 25. Okay, my question is, what is the probability that x is lie between 40 and 60? Now tell me which formula you will use. I didn't mention about lower bound. If I will mention about lower bound, you will go for this, right? So if you see, you have to use this one. Yes or no?
Yes, sir.
This will be greater or equal to 1 minus 1 by k square. Basically, you have to calculate the value of k, then you will get the lower bound. Yes or no?
Yes.
Now, question is, you need what is the value of k? But if you see, this is mu minus k sigma, this is mu plus k sigma, right? Then can I write mu minus k sigma as a 40 or not? Just
Yes.
relate this on this.
Yes,
Can I
sir.
write?
Yes.
Yeah.
What is the value of mu here?
50.
50.
50.
Minus k, what is the sigma?
5.
5, because sigma represents the standard deviation, right? So from here, it will be, can I write 5k equal to 10?
Yes.
K will give you 2.
Sir, what is sigma here?
Sigma is the standard deviation. So this is sigma square variance.
Yeah, okay.
Okay, so k will be 2. Then can I write this is a 1 minus 1 by 4. This will be greater or equal to 3 by 4.
Yep.
Yes or no?
Yes, sir.
So this k equal to 2 you can get from here also. So basically you can apply anyone. So mu plus k sigma equal to 60, right? So basically it will be 50 plus k into 5 equal to 60. Again 5k is equal to 10, k is equal to 2. Okay. Is this clear?
Yes, sir.
Okay. Now okay, so there is some one question. I will take one question from activity, then we can wonder, because you have session, right? So which activity this? I think say we save is activity 3.7.
Sir, in the last example, have you assumed the value of sigma?
No, I didn't assume. I given. I gave in the question.
Okay, okay, sir.
Opening. Wait for a minute. I just I want to take an example from the. Let's say, because so that you can relate. Okay, let's do this one. Question number 3. Okay, what question number 3 says? Suppose a fair coin is flipped 200 times, right? Then find the upper bound. It is clearly mentioned what you have to find upper bound. Okay, on the probability that, okay, first of all, if x is representing, okay, if you are interested in the number of heads, right? So that means x will follow binomial.
Binomial.
Yes or no?
Yes.
So x will follow binomial 200 comma half. Is this information
Yes.
clear? Now,
Yes, sir.
question, you have to find the upper bound on the probability that number of times the coin lands on head. That means probability that, now just try, it is at least 130 or at most 70. So at least 130 means what? X is greater or equal to 130. Yes or no?
Yes.
Or at most 70 means x is less or equal to 70. Would you agree with me?
Yes.
Yes or no?
Yes.
Yes.
And this will be
Yes,
less
sir.
or equal to 1 by k square. Right? But if you see from the formula, this is mu plus k sigma, this is mu minus k sigma, right? Basically, this is mu plus k sigma, this is mu minus k sigma. So basically, we have to calculate the value of k. Would you agree with me?
Yes, sir.
What is the value of mu? This is expectation of x binomial distribution, which is n into p, that is 200 into half, which is 100. And what is the value of sigma square? N into p into 1 minus p, right? Which is variance. So 200 into half, which is 50. Right?
Yes.
So from here, you have to calculate the value of k, right? So I can write mu plus k sigma equal to 130. Right? What is the value of mu? Mu is 100 plus k into sigma is square root of 50 is equal to 130. See, sigma is standard deviation. Sigma square is 50, right?
Yes.
So from here, k into square root of 50 is what? 30. So k will be what? 30 divided by square root of 50. Yes or no?
Yes, sir.
So you will
Yes, sir.
substitute here. So it will be 1 upon 30 divided by 30 square divided by square root of 50 will give you 50. So basically this will be less or equal to 50 divided by 900. Yes or no?
Yes.
So 50 divided
Yes,
by
sir.
900 will be how much?
1 by 18.
1 by 18. That means, yeah, whatever the answer, right? So 1 by 18, let's say, yeah, this is the answer. Now you can see how it's useful, right? The one thing, see, try to solve more number of questions. It will be clear in a minute. The one thing you have to find the value of k. That's all.
Sir, like in such kind of question, like, will this be mentioned? Like, is it following Markov's inequality or Chebyshev's inequality?
See, that is something you have to identify. See, Markov inequality was, it's just all about x is greater or equal to c.
Right. Okay.
Chebyshev is absolute difference x minus mu is greater or equal to k sigma, right? Okay, but in exam, see, for as of our course, we are mentioning whether you have to use Markov or Chebyshev. It will be mentioned, but if you will go for other competitive, but sometimes it's not mentioned. You have to identify the thing. But you will solve when you will solve more number of questions, it will be clear. Okay, that's not a problem at all. Okay.
Sir,
Uh,
sir, can you solve activity 2.11 last question, that geometric one?
Activity 2.11. You are asking
Yes,
to me
sir.
solve the questions from activity 2.11.
Yes, sir. Yes, sir. Yes, sir.
Okay, it's not clear for you.
No, sir. I did not understand what it was asking. Like.
Okay. So one thing I would like to announce. So we are done with week 3. So those who want to attend the session for math, okay, they are free. Okay. So
Sir,
I hope you have learned something from week 3. So I will take this doubt from
So
activity.
on Tuesday, sir, we'll be doing what, sir? We'll be
Solve with the session.
Solving
Thank you, sir.
Thank you, sir.
excuse me, sir.
Yes.
I have a small doubt regarding extra activity, sir. They have asked to take a screenshot of collab notebook, but they didn't mention to send that on website, sir. Do we need to share that screenshot on our website or not?
You can share, right? Let me check. I need to check what is the extra activity.
Yeah, I do have a doubt, sir.
Sir, on Tuesday, we'll be doing exercise, right?
Yeah. I will present one slide. We will.
For week 3. Okay.
Yeah. You have to make a copy, okay, of that collab, and then go through this, and okay, select an
Sir,
Hmm?
the last week instructor didn't share the sessions note with us.
Solve with the PDF.
Prerna ma'am
Okay.
didn't.
Okay. I will check with them. Okay.
Okay. And sir, I have some doubts in extra activity. Like sir, I have to do the given extra activity, the PDF of the Python coding. I copied from there, and what I have to do after that, sir. जैसे मंटे कार्लो कि वहाँ पे कुछ फिर करना है सर, लेकिन उस पे क्या चेंजेस करना है ये मुझे समझ नहीं आ रहा.
You have to perform Monte Carlo, right? Above for the basically. Okay. Okay. Just see the grading criteria, right?
Yeah, grading criteria I have already seen, sir. But उससे समझ नहीं आ रहा अच्छे से. क्लियर नहीं हो रहा है सर.
Okay. What is the due date for this? 5th February.
सर बुधवार को.
Okay.
सर थोड़ा सा ग्रेडेड का क्वेश्चन से थोड़ा कम कीजिए ना सर, बहुत ज्यादा हो रहा है सर.
Is it?
सर हाँ, थोड़ा कम कर दीजिए सर, बहुत ज्यादा लोड हो रहा है सर. एक्स्ट्रा एक्टिविटी, मैथ्स, पाइथन, इस सब का.
Okay. Don't. We'll see. Okay. So. Okay. Let me show you something. Basically, what you can.
Yes, sir. In the last sentence, they have just mentioned take the screenshot of the collab notebook, but they didn't mention it. Whether we have to, yeah.
Okay. Basically, you can. Okay. Let me open. I'm going to share something. So you can basically paste the screenshot of your notebook. Okay, let me show you one submission. This is not for this term. Okay, just for your. You can submit. You can take a screenshot and you can submit like this. Okay, what are the things you have done? Okay, are you getting? Or else, as well as you can submit the link for that thing. Okay.
Okay, sir.
Sir,
Yeah.
I have pasted the link of collab.
Fine, Deepak. You just mention. So the only thing is it should be clearly visible to other peers. They can be easily see. Okay, it shouldn't be like you are able to get. Okay.
Okay, sir.
Is it necessary to do the screenshot and paste that in the?
See, I would suggest you can just go with both, right? So anyway, you have prepared the collab notebook, right? It will take a few seconds to take a screenshot, right?
Yes, sir.
So someone had, I think in activity 2.11, which question you had doubt?
Last question.
Last question, which one? 7th?
Yes, sir. Where we have to calculate the, I think.
Minimum of x and y.
No, no, let me check, sir. One second.
Yes.
Just a second, sir.
Okay, okay. So Sweta and Priyansi has raised hand. Yes. Is there any query?
Sir, can you please explain week 2 graded assignment question 15 and 17?
Question number 15 and 17. Okay, let me take this doubt. Okay.
Yes,
What
sir.
about you, Sweta?
Sir, I still do not have access to the TA session.
No, I have given, right? Can you refresh
No,
and
sir.
check?
I guess last one I have, but previously
No,
two sessions I
you
do
can
not have
cross check. I
access.
have given already. Okay, just refresh and cross check and let me know just now.
Okay, sir. Just a minute. I am
Mhm,
refreshing it.
mhm.
Yes, sir. That minimum one question.
Okay, how did you approach in that case?
Actually, I- there in the lecture, professor explained that one of the formula which includes k. So I thought this question is going to be solved by using that logic, but the value of the k is not mentioned there.
See, first of all, x is following geometric 1 by 6,
Yes, sir.
right?
Yes, sir.
And then x is following 5 by 6. Okay. In
Yes, sir.
case of minimum, so have you seen that one derivation minimum of x comma y, then it will follow geometric 1 minus p1 into 1 minus p2.
Mm, that
Yeah, there is one derivation. So you can find, I think, in last lecture maybe. Okay.
yes, sir.
Give me a minute. I will
But
search and.
in that lecture, we have to calculate the minimum. We need the value of k.
See, K is what? See, it's not about K. Okay, I will show you. Let me search that one. Okay, just give me a second. I'm just searching that video
Yes, sir.
just to show you the what to say, that derivation part. Okay.
Okay.
Yeah, give me a second. Where it went? I think it should be in last lecture only.
2.11 lecture.
Give me that. Give me a second. I think it should be 2.11, right? Yes, 2.11. We at the last.
Fourteen 59 seconds.
Yeah, one second. So basically, you have to. Okay, let me share my screen. Can you see my screen?
Yes,
So I
sir.
think you were at this point only, right? So it's a k, right? K. But if you see at the end, if x follows geometric p1, x2 follows geometric p2, both
Okay.
are independent, then
One
minimum
minute.
will
Yes, sir.
follow 1 minus p1 into 1
Okay.
minus
Okay.
p2, right? So here
Okay, sir.
p1 is 1 by 6, p2 is
5 by
5 by
6.
6, right?
Thank
It's
you.
clear?
Thank you.
Yeah.
Yes, sir.
Yeah. Someone had doubt in.
Sir, can you please explain activity 2.11 same activity or question number 4?
you had doubt in GA or?
Sir, both, in both.
Okay. What is the question number 4? Question number 4 is FZ1 of 1, right?
Yes, sir. In this cumulative frequency, CDF of 1.
So
We have to
FZ of
find.
1, FZ1 of 1 is what is the Z1? Z1 is minimum of x comma y, right?
Yes, sir.
That means probability Z1 is less or equal to 1. Probability of minimum of x comma y less or equal to 1, right? So whenever you have minimum things, right, try to go with just convert into no, not maximum, greater than sign.
Great.
Then in that case you can basically separate the product. Okay, was this had you approached in this way or you approach in some another way?
Sir, I haven't know how to solve it, so I didn't approach in any way.
Then how did you solve this one, third one?
So for third one, we have to find maximum. So it should be the probability of x z should be less than or equal to 1, and maximum of x and y should be less than and equal to 1. Then
Okay.
probability of x should be less than and equal to 1 into probability of y should be less than and equal to 1.
Then you separate it, right? Basically, if you have, okay, there is a very basic concept. So if you have maximum of, let's say 2 comma 3, right? Okay, then in that case you can write this is I mean this is less or equal to let's say 3. So in that case you can write 2 is less or equal to 3 and 3 is less or equal to 3, right?
Yes, sir.
So maximum of 2 comma 3 is 3, right? So basically if I would like to write like this, so can I say this is the case, right? Because I can separate, but in case of minimum, okay, so there is smart approach. Suppose you say minimum of 2 comma 3 is what? 2.
Yes, sir.
Suppose I'm saying this is greater or equal to 2, then I can say 2 is greater or equal to 2 is greater or equal to 2 and 3 is greater or equal to 2. Can I say or not?
Yes, sir.
So smart approach is whenever you have been given a max, so try to convert into less than or equal to sign so that you can separate, and if there is minimum then try to convert in greater or equal to sign.
Here we can do one thing. 1 minus p of x1 x greater than 1 comma y greater than 1.
I will come to that point. Okay, correct. So this is something smart. So this is less than or equal to sign. Then how you can proceed? You can write 1 minus minimum of x comma y greater than 1. Yes or no?
Yes, sir.
Right. If this is the greater than 1, so 1 minus now can I write in bracket probability x is greater than 1 into y is greater than 1? Yes or no?
Yes, sir.
Now you can calculate the probabilities from the table. So 1 minus x is greater than 1 means what? What are the values is taking 2 and 3, right? Basically x is greater than 1, we have to add the probability x equal to 2 plus probability x equal to 3. And y is greater than 1 means only 1. So probability y equal to 2. Calculate the value, substitute here and 1 minus you will get the answer. Okay. Whenever there is a question related to minimum, sorry. So just convert into greater than or equal to sign, and if there is something maximum, convert into less than or equal to sign. Okay, clear?
Yes, sir.
Okay.
Sir, graded assignment question 15.
15. Okay. Don't worry, we will upload the solution. Okay, we have to upload, yeah. But yeah, I will give you the idea. Okay, how to proceed.
सर सॉल्यूशन सर जल्दी से अपलोड कर दीजिएगा सर.
हाँ, correct. Yeah. Okay. So question number 15.
Sir, in this option numbers.
Okay, question number 15.
Oh, 15. No is the answer, I think.
Answer is no. You and we are not. Okay, how will you calculate the two random variables are independent?
Sir, suppose I will take f of x f of x y comma x, and
Basically, in terms of
Product of conditional equals to margin.
condition equals to margin also.
that is also correct. Yeah. So if I will talk about in terms of events, so I have two events A and B. I will say A and B are independent. That means A intersection B, probability of A intersection B is equal to probability of A into probability of B. If I will talk about random variables U and B, I will say probability that f u b or u comma b. I mean joint probability is equal
f of
to
u
product of their
Margin.
marginals.
in that way.
Right. So from here you have been given x and y both are Bernoulli 1/3. X and y both are Bernoulli 1/3. Basically, I can say these two are IID. Now, u is modulus of y minus x and v is x plus y. So, you have to calculate whether x and y, u and v are independent or not. So, you have to, first of all, you need this part, and then you can cross check. So, first of all, what is the range of u and v? What will the range of u? Let's say TU. Tell me.
Sir, it should be for you. It is 0 and 1.
0 and 1. What is the range of v?
Sir, it is 0, 1 and 2.
Clear? Because x can take value 0 and 1, y can take value 0 and 1. So then it can be 0, 0, 1 and 1, 1, 2, right? Okay,
Yes,
this
sir.
is clear. Now what will be the next step? Try to make the columns. Okay, let's say column, what I mean, x, y. Okay, then u, that is absolute difference phi minus x, then v, that is x plus y. Okay, now what are the values for x? So I can write 0, 0, 1, 1. Why should?
Yes,
Because
sir.
0 for 0, 0, 1, 1, 0, 1, 1. Now absolute difference, this will give you 0, this will give you 1,
1.
this will give you, and this will give you
1.
0,
Yes.
and this is 0, 1, 1 and 2.
2.
Then what is the probabilities here? You can find fxy of x comma y. First of all, we will try to find the fxy. Since x and y are independent, right? Because both are
Yes,
following
sir.
same. So what is the fxy? Basically, if you will say fxy 0 comma 0, then what will the probability 1/3 into?
1/3.
Can
It
you
should be 2/3 into
2
2/3,
by
na?
3? Correct. Because this is 0. We are interested in failure. That will be 4/9. Then fxy 0 comma 1, 1/3 into 2/3, that is 2/9.
Yes, sir.
fxy 1 comma 0, again 2/9, and
9.
fxy 1 comma 1, that is 1/9.
1/9.
This one is clear?
Yes,
Now
sir.
you have to calculate the margin. Basically we have to calculate all those things. It will take some time, but I will give you the hint. So probability of u equal to 0 is possible when? Can you tell me? U is equal to, u is taking value 0
And
when?
both are 0.
X and y are 0 and x and y are 1, right?
Yes, sir.
Basically probability that x is 0 and y is 0 plus probability x is 1 and y is 1. What is the probability? 4/9 plus 1/9, which is 5/9.
Yes, sir. Sir, I can do it, the remaining part. I
Right?
found where I am doing wrong.
Okay, very good. Yeah. Okay.
Sir,
All
and
right
question
then.
number 17.
Okay, question number 17. Oh, sorry. Oh,
17 is a part of 16. It's a good question.
what is doubt in question number 17? Question number
Sir, in
16 is
C.
clear.
Yes, sir. Sir,
Yes,
in
sir.
the C option, it is given minus. We have to add both. Why we are subtracting it?
No. We have to subtract from 1.
No, I am not talking about one. I am talking about the. It is asking that non-applicable and flexible both. We have to
Yeah.
consider at least.
They are asking about कम से कम एक होना चाहिए आपकी.
Okay. Let me explain. So if you see, what question is about what? It is asking about at least one occurrence, right?
Yes, sir.
Okay. Okay, let me share my screen. Sorry. Is my screen visible?
No, sir. Now visible.
So question is, if you see, what is the probability that both, right, flexible and non-applicable responses appear at least once? So what do you mean by at least once? So if I will write at least once, okay, at least one means x is tracking greater or equal to 1.
Yeah.
Okay, let's say for if I'm writing at least one occurrence of basically one occurrence of both responses, right? Yes or no? There are two responses, right?
Yeah, sir.
So that can I write this as a 1 minus probability that neither appears?
Yeah, sir.
None
उसका
of them
complement निकालना पड़ेगा.
Correct. Neither appears at all. Can I write or not? If
Yes,
this
sir,
is
we
the
can.
case, right? If this is the case, so if let's say I'm defining event as a, let's say you are saying A as an event, for example, that no one chooses flexible. It's possible, right?
Yes, sir.
No one chooses the option flexible. So that means probability of A is what? No one chooses flexible means 1 minus 1 by 16 raised power n.
Yes, sir.
Right? Let's say you are defining B, no one chooses not applicable. I'm writing A for, right?
1 minus 1 by 16 power n again.
Correct. So 1 minus 1 by 16 raised power n again. So that is 15. Correct?
Yeah.
Now question is, if
Yes,
you
sir.
see, the question is, it is asking about both.
Both.
Right? So both responses appears at least once in the survey results means what?
हमको से neither part को eliminate करना पड़ेगा दोनों का.
Right. So that means, first of all, can I say you have to calculate the union part here?
Yes, sir.
If I'm interested probability of A union B, that is probability of A plus probability of B minus probability of A intersection B. So this will give you 2 times. Yes or no?
Yeah.
Minus what is the probability of A intersection B?
1 minus 1 by 16 minus 1 by 16 whole
That
power
is 14 divided by 16 raised power n.
Yeah.
Right? But this is the probability of A union B, right? But you have to
We have to
see
find out the complement, sir.
complement, right? So this is 1 minus, right? So that's why option C is correct. Is this clear?
Yes, sir.
Yes, sir.
Okay. Yeah.
सर ऐसा क्वेश्चन सर मत दिया करो सर, दिमाग खराब हो जाता है सर.
So no. So this is something आपको सोचना है अभी थोड़ा ज्यादा, right?
ऐसा सोचते सोचते सर दिमाग ही खराब होता है.
So it will give you some confidence when you will attempt for your examinations. Okay. Chalo then. Thanks all. I hope you have learned something. Okay. Yeah.
Yes,
Thank you.
Thank you, sir.
Excuse me, sir.
Yes, Sweta.
Sir, I'm able to access the things.
Okay.
Yeah.
All right. Yeah.
Thank you,
you.
sir.
Yeah. Thank you. Bye.